You know what's wild? Some of the best noise dampening solutions were invented way before we actually needed them. I'm talking about innovations that sat on shelves for decades while the world caught up. Today we're diving into 20 overlooked noise dampening solutions that were literally decades ahead of their time. And hey, if you love learning about forgotten innovations, smash that subscribe button because we dig up these hidden gems every single week. Let's kick things off with something that sounds straight out of science fiction but dates back to the 1920s. Acoustic metamaterials. Yeah, scientists back then discovered they could manipulate sound waves using specially designed structures with properties not found in nature. But here's the kicker. Nobody knew what to do with this knowledge until the 2000s when we finally had the manufacturing tech to make it practical. These materials can bend sound around objects or cancel specific frequencies without any electronic components. We're talking pure physics doing the heavy lifting. The original researchers must be rolling in their graves knowing their work sat dormant for 80 years. Next up is double skin facades. Architects in Germany experimented with this in the 1930s, creating buildings with two layers of exterior walls separated by an air gap. The gap acted as a massive sound buffer while also providing insulation. But construction costs and complexity meant nobody touched this idea seriously until the late 90s when energy efficiency became a priority. Now every modern skyscraper uses some variation of this concept. Took us 7 decades to realize those German architects were onto something revolutionary. Here's one that'll blow your mind. Anechoic chamber principles were first developed in 1919 at Bell Labs. These are rooms designed to completely absorb sound reflections, creating the quietest spaces humanly possible. The wedge-shaped foam patterns you see today, that design language comes from those original chambers. But for decades, only research facilities used them because regular people didn't understand why you'd want a silent room. Fast forward to today and recording studios, testing facilities, and even high-end home theaters use anechoic principles. Only took a century for the rest of us to catch on. Moving on to something hiding in plain sight, tuned mass dampers for vibration control. Engineers in Japan developed these in the 1920s originally for earthquake protection, but they realized these systems also crushed noise from structural vibrations. Picture a massive pendulum inside a building that swings opposite to building movement, canceling out oscillations and the sound they create. Taiwan's Taipei building has a visible one weighing 660 tons. The tech existed before most skyscrapers did. Talk about being ahead of the curve. Let's talk about resilient channel mounting systems. Invented in the 1950s, this simple idea involved mounting drywall on flexible metal channels instead of directly to studs. The air gap and flexibility meant sound vibrations couldn't transfer through walls easily. Seems obvious now, right? But builders largely ignored this until the 1980s when apartment living made soundproofing essential. 3 decades of people suffering through paper-thin walls because nobody wanted to add a simple metal channel. Classic human behavior right there. Here's a nautical gem. Anechoic tiles for submarines were developed by Germany and the United States during World War II. These rubber tiles with specifically designed air cavities could absorb sonar pings, making subs nearly invisible. The same principle works for any sound frequency. After the war, this tech was classified for decades. When it finally went public in the 80s, industrial facilities started using similar tiles for noise control. Military secrets from the 40s solving factory noise problems in the modern era. Cork underlayment is another overlooked hero. Portuguese manufacturers in the early 1900s discovered cork's amazing sound dampening properties for flooring. Natural, renewable, effective. But synthetic materials dominated the market for nearly a century because they were cheaper to mass produce. Now in our eco-conscious age, cork underlayment is having a massive renaissance. Architects are installing the same product that existed when their great-grandparents were kids. Sometimes the old ways really are the best ways. Pneumatic noise barriers might sound futuristic, but they date back to the 1930s. Engineers realized inflatable structures filled with air or foam could create temporary sound walls for construction sites. Lightweight, portable, effective. Yet this tech barely got used until the 2000s when urban construction made noise complaints skyrocket. Those original pneumatic barriers would have saved countless headaches if anyone had actually deployed them at scale. 7 decades of missed opportunity. Green walls or living walls for sound absorption were first scientifically studied in the 1940s. Researchers found that plants' soil and growth medium could absorb and diffract sound waves incredibly well. Plus they look amazing and clean the air. Seems like a no-brainer, right? Wrong. It took until the early 2000s for green walls to become trendy in architecture. 60 years waiting for aesthetics and environmentalism to align with acoustic science. Fabric duct systems were invented in the 1960s as a quieter alternative to metal ventilation. The porous fabric diffuses air silently and absorbs duct noise. Commercial kitchens and clean rooms loved them, but mainstream construction ignored fabric ducts for 40 years. Now they're everywhere in modern buildings because architects finally realized silent air distribution is actually valuable, 4 decades late to that particular party. Here's one from left field. Electroheological fluids for adaptive sound damping were discovered in the 1940s. These fluids change viscosity when electricity runs through them, meaning you can tune their sound dampening properties in real time. Sounds like magic tech from the future, right? Well, it's been around for 80 years. Only recently have we started putting these fluids in high-end automotive suspensions and industrial equipment. The original inventor probably imagined flying cars using his fluid, not luxury sedans in 2020. Phase interference noise cancellation without electronics was theorized in the 1920s. Physicists understood that careful architectural design could make sound waves cancel each other out through strategic reflections and path lengths. Ancient amphitheaters accidentally used this, but modern intentional applications didn't happen until the 90s. We had the math for 70 years before anyone built it into concert halls and auditoriums. Sometimes theory and practice take a while to reunite. Microporous metal foams for sound absorption were developed in the 1950s for aerospace applications. Imagine metal that's mostly air, with tiny interconnected bubbles that trap sound energy. Lightweight, fireproof, and incredibly effective, but manufacturing costs kept it in specialized aerospace use only. Now with advanced production methods, microporous metals are showing up in automotive and architectural acoustics. 5 decades as an aerospace secret before going mainstream. Granular damping systems using sand or shot inside hollow structures date back to the 1930s. Engineers discovered that filling hollow beams or panels with granular material could eliminate resonant vibrations and associated noise. Machine tool manufacturers loved this trick but kept it proprietary for years. Construction didn't widely adopt granular damping until computer modeling in the 2000s proved just how effective it was. 70 years of builders reinventing wheels they could have just filled with sand. Sound-absorbing concrete was patented in the 1970s. By adjusting aggregate size and creating interconnected pores, engineers made concrete that absorbs sound instead of reflecting it, perfect for highways and urban areas. But standard concrete was cheaper and the acoustic benefits seemed too niche. Flash forward to today and noise pollution regulations are driving massive demand for this 40-year-old invention. Regulations finally caught up to innovation. Sonic crystals or periodic structures that create acoustic band gaps were theorized in the 80s, but the concept traces back to 40s era physics. Arrange obstacles in specific patterns and certain sound frequencies simply cannot pass through. No power needed, just clever geometry. Artists and architects only started playing with sonic crystals in the last 15 years. Decades of pure physics waiting for creative minds to exploit it. Constrained layer damping was developed for military aircraft in the 1950s. Sandwich a viscoelastic material between two rigid layers and vibrations get converted to heat, killing noise at the source. This tech sat in classified aerospace applications for decades before automotive and construction industries discovered it in the 80s and 90s. 30 to 40 years as military-exclusive tech before helping quiet your daily commute. Diffusive surface geometry based on mathematical sequences comes from the 70s. Acoustic engineers used number theory to design wall surfaces that scatter sound evenly without absorbing it, critical for spaces like concert halls where you want sound to be lively but not echoey. Most architects had no idea this math-based approach existed until the 2000s when simulation software made it accessible. 3 decades of hit or miss acoustic design while the formula sat in research papers. Water features for acoustic masking have been understood since ancient Rome, but scientific applications emerged in the 1930s. Moving water creates broadband noise that masks unwanted sounds without seeming loud itself. Offices and public spaces ignored this elegant solution for decades, relying instead on white noise machines. Now biophilic design has made water features cool again. We really do go in circles sometimes. Last but definitely not least, active structural acoustic control was theorized in the 60s. The idea was to put sensors and actuators on structures to detect vibrations and counter them in real time, eliminating noise before it radiates. Sounded like pure fantasy back then because the computing power didn't exist. Now in the 2020s we finally have processors fast enough to make this work in real-world applications. 60 years from theory to practice. Some ideas just have to wait for technology to catch up. And there you have it, 20 incredible noise dampening solutions that were sitting right under our noses, sometimes for nearly a century, waiting for the world to realize their value. It makes you wonder what innovations we're overlooking right now that'll seem obvious 50 years from today. If this video made you think differently about forgotten tech, hit that like button and subscribe for more deep dives into innovations that time forgot. Drop a comment telling me which of these solutions surprised you most. Thanks for watching and I'll catch you in the next one. Thinking about all these innovations really puts into perspective how much human ingenuity we leave on the shelf. It's not just about noise dampening either. This pattern repeats across every industry imaginable. We develop something brilliant, the world isn't ready for it, and then decades later we act like we invented it all over again. It's almost like we're collectively searching for the same solutions twice. What really fascinates me is the gap between when something is invented and when it becomes practical. Take those acoustic metamaterials we talked about. The science was solid in the 1920s. The math worked, the principles were proven. But without the right manufacturing technology, without computer modeling to show its potential, without the market demand finally existing, it just sat there. It's like having the instructions to build a house but not having power tools. You technically could do it, but good luck getting anyone excited about the project. And that brings me to something important that I think we should all consider. Right now, in this very moment, there are probably innovations sitting in laboratories and research papers that won't hit the mainstream for another 30 or 40 years. Some brilliant physicist or engineer has probably already figured out something that will change how we live, but the world isn't ready. The infrastructure doesn't exist. The market demand hasn't materialized. The cost is too high. Sound familiar? It's the same story we've been seeing throughout this entire video. The resilient channel mounting systems are a perfect example of how absurdly simple some solutions can be. We're talking about a thin metal channel. That's it. Not expensive, not complicated to install, but somehow it took 30 years for builders to adopt it even though the acoustic benefits were known from day one. Sometimes the barrier to innovation isn't technology at all. It's just convincing people that a problem is worth solving. It's changing ingrained habits and construction practices that have been around forever. I think about the green walls and living walls situation a lot. Here we had a solution that was not only effective at dampening sound but also improved air quality and looked beautiful. Triple threat. Yet it languished for 60 years waiting for the planets to align. We needed green building standards to matter. We needed people to care about plants and nature in their urban spaces. We needed Instagram to make it look cool. Only then did everyone suddenly realize this 40-year-old solution was exactly what they wanted. The water features point is even more interesting because it shows us that sometimes the oldest solutions are the best ones. Humans have known for thousands of years that water sounds are calming and pleasant. Roman architects understood this. Medieval monks built fountains in their courtyards intentionally. But modern architects and office designers basically forgot this entirely. We got caught up in sterile efficiency and forgot that our ancestors had already solved this problem beautifully. Then someone rediscovered it in the 1930s, we ignored it for decades, and suddenly now it's everywhere again. We're literally remembering solutions we've already forgot. The constrained layer damping thing really illustrates the military-industrial timeline too. Military applications always seem to get the cutting-edge technology first. They have the budget, they have the urgency, and they have the security clearance to keep things secret. So visionary military engineers figure something out in the 1950s. It stays classified for 30 years. And then the rest of society eventually gets access to this breakthrough that's already ancient history in defense circles. It's a weird lag in innovation distribution. What strikes me most about this whole collection of forgot solutions is how often they were invented in times of crisis or necessity. The anechoic tiles came from World War II. The tuned mass dampers came from earthquake research. The pneumatic barriers came from early industrial challenges. Innovation seems to spike when we absolutely have to solve a problem immediately. Then when the crisis passes, we forget about the solutions because we're no longer motivated by urgency. We move on to the next problem instead of perfecting the ones we've already solved. The microporous metal foams are such a fascinating case because they perfectly demonstrate the cost barrier to innovation. The technology was great, the performance was unquestionable, but it was expensive because manufacturing it required specialized aerospace-grade production. So it stayed locked in the aerospace industry for decades while everyone else suffered with inferior noise control solutions. Only when automation and new manufacturing techniques made production cheaper did the rest of us finally get access to this 50-year-old invention. Economics and accessibility are often bigger barriers than actual technological capability. I'm also struck by how many of these solutions required better computers and simulation software to become mainstream. The diffusive surface geometry based on mathematical sequences is a perfect example. The math existed in the 70s. The principle was sound, no pun intended. But you needed computers powerful enough to calculate and model these complex geometries to really prove their worth. Once CAD software and acoustic simulation became standard tools in the 2000s, suddenly everyone wanted sonic crystals and mathematical diffusers. Technology enabling technology, it's turtles all the way down. The active structural acoustic control story really drives home how sometimes a solution is just born too early. The 60s is when someone dreamed up this elegant idea of sensors and actuators actively canceling vibrations in real time. Amazing concept. But the computing power required was science fiction at that point. You'd need massive mainframe computers running constantly just to control one building. So the idea sat in theoretical physics papers while buildings continued to vibrate and resonate noisily. Now in the 2020s, we have processors so powerful that they fit in your pocket. The solution that seemed impossible in 1966 is now becoming practical reality. This whole journey makes me think about how we should approach innovation differently as a society. Maybe we should be spending more time reading old research papers and patents instead of always chasing the newest thing. Maybe there are solutions from the 50s and 60s and 70s that are actually perfect for the problems we're facing right now. We've got the technology to implement them. We've got better understanding of why they work. We just need someone to actually try bringing them back and updating them for modern applications. There's also something really humbling about realizing that some of our greatest innovations were already invented before we were born. Our role isn't always to create something brand new from scratch. Sometimes it's about recognizing what was already created, understanding why it failed before, and figuring out how to make it work now. That's actually a higher level of innovation in some ways. It requires understanding not just the technology but the market conditions and societal factors that determine success or failure. I keep coming back to those German architects in the 1930s with their double-skin facades. They were creating the exact same building standards that we now consider cutting-edge in the 2010s. They understood passive thermal performance, sound management through air gaps, and intelligent facade design. Nearly 100 years later, and we're treating these concepts like they're revolutionary breakthroughs. What would those original architects think if they could see that their ideas are just now becoming standard practice? I imagine they'd be equal parts vindicated and frustrated. The cork underlayment renaissance is actually really encouraging though. It shows that sometimes forgotten solutions can make a comeback when the values of society shift. For most of the 20th century, synthetic was better because it was cheaper and newer seemed better than old. Now in our environmentally conscious age, suddenly the solution that was invented in the 1900s is trendy again. It's a good reminder that technological progress isn't always linear. Sometimes we have to circle back and realize that the old way was actually the right way all along. All of this brings me to an important realization about innovation cycles. We tend to think of progress as always moving forward, always towards something newer and more advanced. But the real pattern seems to be more like a spiral. We invent something, we forget about it, we reinvent it, we forget again, and eventually we remember it was always there. The timeline might be short now with better communication and documentation, but the fundamental pattern persists. Maybe that's just human nature. We're always looking for the next big thing instead of perfecting what we already have. The fascinating part is how many of these solutions would actually help us right now if we just adopted them more widely. We still have noise problems. We still have buildings that aren't soundproofed properly. We still have infrastructure that vibrates and resonates and creates unwanted noise. The solutions exist. Most of them have existed for decades, sometimes over a century. The question is never whether the technology works. The question is always whether we're willing to implement it. That's a cultural and economic question, not a technological one. So as we wrap up this deep dive into forgotten noise dampening solutions, I want you to think about what this pattern means for your own life and your own work. What problems are you trying to solve? Have you checked to see if someone already solved them 50 years ago? What old ideas might actually work better than the new solutions you're considering? Sometimes the best innovation isn't inventing something new. It's remembering something old and giving it a second chance in a new era. Thank you so much for sticking with me through this exploration of overlooked innovations and forgotten genius. If this video made you see technology and innovation in a new light, please smash that like button and subscribe to this channel. We dive into stories like this every single week, uncovering the hidden history of innovation and the brilliant minds who were decades ahead of their time. Drop a comment below and tell me which of these solutions shocked you the most, or if you know of any other forgotten innovations that deserve to be remembered. Your insights and stories mean everything to us and help shape what we cover next. Thanks for watching, and I'll catch you in the next one where we explore even more of the forgotten innovations that shaped our world.